What's up guys, Angad here and welcome back to another video. Today we are going to be looking into transformations. I'll be explaining transformations in an extremely simple way so you guys can ace it. Before we start, please make sure to like and subscribe to the channel. Now let's get started. The most basic and easiest part of transformation is vertical translation. So let's start with that. Vertical translation is written as f of x plus minus k, as you can see over here. If k is positive, the graph will move k units up, and if it's negative, it will move k units down. So supposing we have an equation f of x is equal to x squared. G of x is equal to f of x plus 2. This means that the graph will move x squared plus 2 units up, and h of x is equal to f of x minus 2. This means the graph will move minus 2 units down. So I just drawn it over here. So f of x, this is a normal x squared graph that all of us are aware of. G of x will be f of x plus 2 units. So as you can see over here, it will be 2 units upwards, and h of x will be 2 units down from the normal origin. So over here you can see how I sketched the graph 2 units down. Now let's do horizontal translation. Horizontal translation is written as f of x plus minus k, where k is inside the bracket. If k is positive, it will move k units to the left. If it's negative, it will move k units to the right. So for example, if you have a graph f of x is equal to s square, you write g of x is equal to f of x plus 2 and plus 2 inside the bracket. The graph will move 2 units to the left, and h of x is equal to f of x minus 2 inside the bracket. The graph will move k 2 units to the right. You can see how I've drawn here. The first graph is an example of f of x as a standard x squared graph. Second graph is an example of g of x, where it moves 2 units to the left. Third graph is an example of h of x, where it moves 2 units to the right. Now let's move on to dilation. There are two types of dilation: vertical stretch and horizontal stretch. Let's first deal with vertical stretch. Vertical stretch is written as f of x is equal to x squared, so then g of x will be 2f of x, 2 being outside the brackets. So in case of vertical stretch, there's one important thing to remember, that x comma y is actually becomes x comma 2y. So y is multiplied by the scale factor, and the value of x coordinate remains unchanged. So for example, if f of x is equal to x squared and g of x is equal to 2f of x, the graph g of x will be just thinner compared to the original graph, since the y coordinate is multiplied by 2 each time. Now let's move on to horizontal stretch. Horizontal stretch is written as f of x is equal to x, and then g of x is equal to f of 2x, 2 inside the bracket. In horizontal stretch, we have to remember it's x by c comma y. The x coordinate is divided by the scale factor, which I've written as c over here, and the value of y remains unchanged. So for example, like I've taken f of x is equal to x and g of x is equal to f of 2x, I have drawn the diagram over here for it. So the x coordinate is divided by the scale factor, while the y coordinate remains unchanged. Reflection is the final transformation we are going to be covering today. There are two types of reflection, on the x-axis and on the y-axis. And the function is written as f of x and minus f of x with the minus outside the bracket. That's reflecting on x-axis. And when the function is written like f of x and then f of minus x and the minus inside the bracket, that's reflection on y-axis. So basically all you have to do is reflect on the axes. So f of x is equal to x squared, g of x is equal to minus f of x. So all you have to do in this case is reflect the graph x squared on the x-axis. So that's what I have done over here. I'm sorry, my diagrams are not very accurate. I apologize for that. And the second graph I get f of x is equal to fx, g of x is equal to f minus x. So then I have to just reflect it on the y-axis, and that's what I've done. Reflection is a very easy transformation. So that's all for now. Now you're a master at transformations. Thank you for watching this video. Make sure to subscribe and hit the bell icon for future videos. If you have any doubts, do let me know in the comments below. But for now, thank you.